Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another lesson, and today we are in week 3, which is the periodic table. And inshallah, we will learn quite a bit about the periodic table today. These are the learning objectives that we will be covering today, mainly this one here, to identify the data about the elements found in the periodic table and explain how the periodic table is useful. Okay, let's keep going. What does the periodic table include? So the first thing you need to understand is the periodic table basically is a table of elements. It contains 118 elements that scientists have discovered, and these elements are like Legos. They make up everything in the universe. Everything in the known universe that we know currently is made up of a combination or a mixture of these elements. So if you look at your own body, for example, you're made of mostly carbon, but you also have oxygen, hydrogen, argon, and nitrogen inside you. That's basically 99% of you. Carbon, nitrogen, oxygen, hydrogen, and argon. But there are different elements, as I said, and different mixtures or combinations of these elements will make different things. So if you look at water, for example, water is, as most of you know, is H2O. So what does that mean? It means it's made of hydrogen, and oxygen. And this is a molecule of water. And a molecule is just a fancy way of saying that it's the smallest compound of water, or the smallest form of this compound, which is 2 hydrogens and 1 oxygen. So the 2 that comes after the hydrogen refers to the hydrogen. So we've got 2 hydrogen atoms combined means fused, with 1 oxygen atom, and that forms water. Okay, so that's just one example of a compound, and of course we've got millions and billions of compounds. So that's basically, in short, what elements do and how the periodic table works. So if you look at the alphabet, for example, we've got 26 letters, but using those 26 letters we can form so many different words, and so many different books have been written, and so many different stories, and so many different scripts. And it's a bit like that. So we've got 118 different elements, but they form every single thing out there. Okay, it's very interesting stuff. So how are the elements presented in the periodic table? Well, first of all, I think what I need to do is I need to show you what a periodic table looks like. So this is what a periodic table looks like, or this if you prefer. And as you can see, this is where all the elements are. And so we start with 1 over here, hydrogen, which sometimes is written separately, as in some periodic tables, like, let me just show you something, like this one here, has hydrogen on its own. Okay, and that's fine as well. That's quite interesting because hydrogen is a unique element, and we'll come to talk about hydrogen a bit more as we study about it. But in short, hydrogen has been put with the metals, but it's not really a metal, and so it's a non-metal and belongs to group 1, and it's the most abundant element in the universe. It doesn't have any neutrons. It's the only one with no neutrons that occurs naturally. It's been referred to as a proton. It's a very interesting element. I will talk more about hydrogen as we move on. Right, so back to our lesson. So as we said, they're presented in this manner. So we've got something called the chemical symbol, and the chemical symbol is this guy here. Okay, so this, in this case, O refers to oxygen. Then we've got something here called the atomic number, and the atomic number, of course, refers to the proton number. So you should know this by now. The atomic number is the number of protons, and that is the ID card of the atom or the element. Okay, so the element, the identity of the element is through the atomic number or the number of protons. Sometimes you'll see the name underneath, sometimes you won't. Sometimes you just see the symbol, and it depends on whether they're trying to save space or not. And then you've got the mass number, and of course the mass number is a combination of the number of neutrons which live inside the nucleus and protons which also live inside the nucleus. So why do we have decimals here then? If you remember from my previous lesson, I said the reason why we have decimals is because it's the average of all the different isotopes of the element in nature. Okay, so let's say for example you've got chlorine 35 or chlorine 37. It depends on how the percentages of their existence. Let's say for example chlorine 35 exists 90% more often than chlorine 37, then this here, this number will represent the average of their abundance in nature. Okay, so that's why you've got decimals. Right, let's move on. So I've already talked about the atomic mass. The atomic mass is basically the number of neutrons and the number of protons that an element has. That's what we mean by atomic mass. The atomic mass is the number of protons and the number of neutrons the element has. And the periodic table, of course, is a chart. This is what I want you to make sure that you understand. It's a chart showing all the elements arranged according to repeating patterns in their properties. So yes, that is true, but it's also a chart that is arranged according to atomic number. So the first element in the periodic table has 1 proton, okay, which is hydrogen. The next one, helium, has 2, and that means it has 2 protons. Lithium has 3, beryllium has 4, boron has 5, and carbon 6, nitrogen 7, oxygen 8, and so on and so forth. So it is arranged by atomic number. It's also arranged by atomic properties. So what does that mean? What that means is it's not just randomly put in place, otherwise it'd just be a train, wouldn't it? It'd just be a straight line. As you can see, it's got this strange shape to it. Why does it have this strange shape? Well, the reason why it's got a strange shape is because it's in groups and it's in periods, okay? And we'll talk about those in a minute. But basically, we've got this guy, his name is Mendeleev, and he's a Russian scientist, and he was one of the first people to give this a real serious thought and think, well, what's going on here? What is this business with elements and where do they belong and so on and so forth? And he came up with the first periodic table, which we have over here. And as you can see, it was quite a basic periodic table. It was a basic chart. It didn't have all the elements on it that we have today. And that's normal considering back in their time, they didn't quite have all the lab equipment that we have today or the knowledge that we have today. So what did Mendeleev propose? He proposed that there were quite a few elements and that some of them are quite similar to each other, and he arranged them in such a way that he put the ones with similar properties together, and he came to quite an astonishing conclusion, and that is that elements showed patterns. It's simple, it's quite a simple conclusion, but it's quite an astonishing one. Elements showed patterns. So what does that mean? It means that there were patterns in each group. Basically, whether it came to reactivity, whether it came to oxidation, or how they formed compounds, or whether they were stable or not, all of those things became apparent for certain elements. And so that's what he decided to do. He decided, let's form a periodic table and put the elements in order and see what comes up. And he was so clever that he could predict that in the future we were going to discover certain elements that he hadn't discovered yet. So what did he do? In his periodic table he had gaps, and you will see some of those gaps here. For example, there's a gap, there's no element there. However, there's one here, but there's no element before it. And there's another one here. Now, Mendeleev was very smart. He didn't just fill in the gap, or he didn't just ignore the gap and just, put something in there. He knew that in the future there would be an element discovered that had the properties that were missing. So, That's why he left the gaps, because he knew, okay, there has to be an element there that I haven't discovered, he thought to himself. But someone will come along one day and they will fill in the gap. And that's exactly what happened. So he was very clever, and he was ahead of his time. And he came from a very poor family, actually. This is quite an interesting story. There's quite a few videos on him on YouTube, and I highly urge that you look into his background. It's quite interesting. Anyway, we've got a question here. Explain, how is the modern periodic table different from Mendeleev's periodic table? The modern periodic table shows additional elements that had not been discovered during Mendeleev's time. Also, elements are now listed according to increasing atomic number instead of increasing atomic mass. Okay, so back then, Mendeleev started off by listing the periodic table according to the atomic mass, which of course, as we know, atomic mass is proton number as well as neutron number, both of them together, proton number and neutron number. However, today we only go by proton number, which is the ID of the element. Okay, so using the periodic table. The periodic table contains information about each of the known elements. Okay, it includes the name of the element, its chemical symbol. That is called the chemical symbol. Okay, so in this case we've got phosphorus. This is the name of the element, and sometimes it's listed and sometimes you'll see that it's not listed. So it depends on the type of periodic table that you've got. Okay, and here we've got a representation of phosphorus, as I've said, and of course over here you've got the atomic mass, and most of the time we don't have these decimal places, especially at this stage. What we have is a nice round number, and that kind of makes sense because of course you can't have parts of neutrons or parts of protons, not really. So then what we have is, this is the average, and you'll see here that it's measured in atomic mass or atomic mass units, AMUs, and it's the average, as you can see here, the average, because most of the elements consist of a mixture of isotopes. So it's hard to find an element in its pure form. Usually it's a mixture of one or two isotopes of the same element. Okay, and here we've got zinc, for example. Zinc is atomic number 30. The atomic mass of zinc is 65.38, and so on. Okay, so I hope that's not too complicated. What about oxygen? Let's do one of our own. Oxygen. If I had oxygen, what would be the atomic mass of oxygen? So the atomic mass of oxygen is 16. The atomic number of oxygen is 8. And of course the name would go over here. Okay, and that's how that one works. Let's keep going. So here we are, the periodic table in all its glory. So what do we have here? What we have here is the periodic table, and as you can see, it's got this funny shape. Now, why is it arranged the way it is? Well, turns out there's these things here that we call groups. So this is group 1, this is group 2, this is group 3, this is group 4, and so on and so forth. Each one of those columns is a group. That's a column, that's a column, and that's a group, that's a group, that's a group, that's a group, and that's a group, and that's so forth, and so on and so forth. So this here is a group, for example, in pink. And this group is known as the noble gases. Then we've got another group over here, and that's known as the halogens. And here we've got the oxygen group. Why is it called the oxygen group? Because it starts with oxygen. Here we've got, what kind of group is this? What does it start with? Nitrogen, so it's called the nitrogen group. We've got the carbon group, and we've got the boron group. Over here, although that's called the beryllium group, it's also known as the alkaline earth metal group, this one here. Then we've got the alkaline metals, and these are my favorites. They're highly reactive. Okay, they make all sorts of sparks and fires when you mix them with water and acids. So in short, the periodic table is divided into different groups and different periods. Wait, hang on a minute. We haven't talked about periods. We've talked about groups. Those are groups. The columns are groups. But what about the periods? So the periods are these guys here. Okay, so this is a period. Each one of those is a period. That's the first period. Hang on, let me just show you the first period. That is the first period. That's the second period. That's the third period. Okay, so we've got periods and we've got groups. The rows are the periods and the columns are the groups. Okay, and it's arranged according to properties and it's arranged according to atomic number. So the first and foremost, it is the periodic table is shows the elements according to increasing atomic number. So what that means is we start with hydrogen with an atomic number of 1 proton, and then helium has 2, and so on and so forth until we get to 118. But also we've got elements arranged according to their properties and their groups. So the groups of elements, each group, so group 1 has similar properties, and group 2 has similar properties, and group 3 has similar properties, and group 7 has similar properties, and group 8 has similar properties. So if you have similar properties or you belong to the same family, group or family, same thing, same. So we're referring to columns here. So a column, a group, or a family are all the same. If you belong to the same family, if you belong to the same group, if you belong to the same column, then you are considered an element of similar properties. So if we look at noble gases, another one of my favorite group of elements, noble gases, you'll notice something here. They are completely non-reactive. And the reason why they're non-reactive is because noble gases don't need anyone's electrons. You see, this is the moment when I take a step back and explain the use of electrons. You see, we've talked about protons. We said protons are basically the identity of the element. The ID of the element depends on the protons. If it's got 6 protons, then it's carbon. If it's got 8 protons, then it's oxygen, and so on and so forth. Neutrons have to do with stability, and they're inside the nucleus of the element. And if you've got too many neutrons, then you cause radioactive decay and so on. But what about electrons? Electrons are to do with reactivity. So you know how certain elements react with other elements, or they spark, or they explode, or they heat up when you put them in different elements? Well, that's got to do with their number of electrons. Okay? Well, it turns out part of the reason why the elements are arranged the way they are here is because you'll notice that elements in the first group, so this is group 1, have 1 electron on the outside. What does that mean on the outside? Well, remember how we said that elements have a nucleus in the middle, and then we've got these orbit-like structures. And so this is lithium, for example, and lithium has 2 energy levels, or 2 orbits, so 2 shells. We've got the one on the inside with 2 electrons, and we've got the one on the outside with 1 electron only. Now, why does it have 1 electron only? Well, let's look at lithium as an element. Lithium has 3 protons. It's got Li as a chemical symbol, and it's got 7 as a mass number, or AMU. So what does that mean? It's got 3 protons. If it's got 3 protons, how many electrons does it have? Most of you should know this by now. If it's got 3 protons, then that means it's got 3 electrons, right? 3 protons, 3 electrons. So if it's got 3 electrons, how are they arranged? Well, it turns out they're arranged in such a way that there's always 2 on the inside and there's 1 on the outside. 1 on the outside. Only 1 on the outside. So is that a problem? Well, it can be. You see, lithium wants to be stable. And how can lithium be stable? The only way lithium can be stable is if it's got a complete shell. Now, either it's going to lose this electron, and if it does, then it doesn't have to worry about it, then it's got a complete shell. Or it's going to gain a few more electrons so it can have a complete outer shell. You see, lithium, like every other element, wants to complete its outer shell. It wants to have a complete number of electrons in its outer shell. On the inside, a complete shell would mean 2 because it's a small circle. On the outside, a complete shell would mean 8 electrons. Okay, so that's just the way it is. We've got 2 in the inside, and we've got 8 on the outside, and then we've got another 8 on the third shell. That's as far as you need to know for now. So what happens here then? Well, it's got 2 and it's got 1, but it really doesn't like that one. It doesn't want it because, as I said, it wants a complete outer shell. And the easiest thing to do for lithium would be to get rid of it altogether. So that makes lithium very reactive. Okay? Lithium is very reactive. So if you put it with water, what is it going to do? It's going to try and get rid of that electron very quickly. Now, getting rid of that electron is just a fancy way of saying it's going to react. And that's the gist of it. Okay, so I hope you understood that. Basically, if an element is trying to get rid of its electrons, or if it's trying to gain electrons, and it's trying to do that rapidly, that is what we call reactivity. That's what we say that element is very reactive. Okay? So that's lithium for you. Now, what about sodium? Well, sodium is under lithium, but sodium has 11. Sodium has 11 electrons. So what does that look like? Well, remember we said lithium has 3. So lithium looks like this. 2 on the inside and 1 on the outside. Sodium has 11. So 2 on the inside, 8 on the outside. So what does that make? 10. And then there's 1 left over as well. Same as lithium. And because it's got 1 left over as well, that means it's got a similar reactivity to lithium, except it's slightly more reactive as well. So lithium is reactive. Sodium is even more so, because it really wants to get rid of it. What do you think potassium is going to behave like? I think some of you figured it out. Potassium is going to be even more reactive. So this is what happens. As you go down the periodic table, the elements become more and more reactive. So over here, certainly in the first group, they have similar reactivity, and they are more spontaneous, and they make bigger explosions as you go down the periodic table. What about these guys here? The alkali earth metals. So these guys are also reactive. Not as reactive as the first group, but they are also very reactive, and their reactivity increases as you go down the periodic table. Okay? These ones here are also very reactive for a different reason. These ones here are missing an electron as opposed to having an extra electron. They're actually missing one. So as you can imagine, let's say fluorine, for example. Fluorine has 9 electrons, so it's got 2 on the inside, because you always have 2 on the inside, and it's got 7 on the outside. So as you can see, it's missing 1. It wants 8 to make a complete shell. So where is it going to get that one from? Well, it can get it from a whole assortment of elements. But let's say, for example, fluorine meets lithium. We've got lithium, which has 1 extra electron, and it wants to get rid of it. And we've got fluorine that really wants an electron. So what's going to happen when lithium meets fluorine is it's going to form a compound of lithium fluoride. And lithium fluoride is going to be a very happy, stable compound. Fluorine becomes happy because it's got a complete shell. And then lithium becomes happy because it's also got a complete shell. And everybody's happy. Okay? So that's what happens with elements. I know it's a very simplistic view, but I just wanted to get those ideas across to you. basically the reason why the elements are in the periodic table the way they are is because of the atomic number, and the way they're in their groups is because of their valence electrons, or the electrons on the outside. Okay, and each one of those groups has certain properties or certain features. So we've got groups, we've got periods, we've got 1 to 18 as groups, or 1 to 8, and we've got 1 to 7 as the periods. As you can see here, that's period 1, 2, 3, 4, 5, 6, 7. So 7 periods. And how many groups? As you can see on top, we've got 1 to 18. Okay, but if we ignore those in the middle, the transition metals, then we've got 1 to 8, right? So we'll come to know more about those soon as well. Okay, so that's just a very quick summary of the groups and the periods of the periodic table. So it turns out the elements are also arranged in these broad categories. So if you're an element, you're either metal or non-metal. That's it. You don't have any other choice. Or is that right? Well, you can also be kind of in between both. So everything here is what we call a non-metal. Let me just get rid of lithium fluoride there. Non-metal. While everything over here is what's known as metallic elements, or metallic. What about this group here, this slice in the middle with the dark green? Well, these are metalloids. Metalloids. And what that means is they're halfway between metals and non-metals, or they kind of show the properties of both. Okay? So it's very interesting. The periodic table is divided into metals and non-metals. And these metals and non-metals are arranged in such a way that they're in certain groups and certain periods. Okay? So let me repeat that one more time. How many elements in the periodic table? 118. How are they arranged? By atomic number, by the number of protons. How else are they arranged? They're arranged in groups. Groups are columns. And these groups are according to their properties. They're according to the number of electrons they have on the outside. Okay? So groups that have the same number of electrons on the outside, they have same properties. Like for example, alkali earth metals, or alkaline earth metals, or alkali metals. We've got some that are stable, and we've got some that are not stable at all. Okay? But that's how they're arranged. They're arranged in columns, they're arranged in periods, and they are either metal or non-metal. That's all I want you to know for now. Okay. So let's have a look over here. So the periodic table is also organized into groups and periods, as we've said. So this here is considered as a period. Okay, and how many periods have we got? We've got 7 periods. Okay, we've got 7 periods. So the period is a row in the periodic table, and there are 7 periods. And here is a group, and we've got 18 different groups in the periodic table. And so you might be curious about these guys here. These are called the lanthanides and the actinides, and they're also rows, okay, but they're part of row 6 and 7. Okay, so they just come out of here. Okay, let's keep going. So let's talk about the different groups in the periodic table. So the first group is the alkali metals, and it starts with lithium, Li. The next group is called the alkaline earth metals, that have got magnesium, Mg, transition metals, gold, Au, carbon is C, boron is B, the boron group, the nitrogen is the nitrogen group, or N, sulfur is S, phosphorus is B. Okay, so that's how the periodic table, the groups of the periodic table are arranged. Okay, so let's read some of these properties. The metal the metals of group 1 from lithium all the way to francium are called the alkaline metals. Alkaline metals are so reactive that they are never found in as free elements in nature. Why can't they? What does that mean? They're never found as free elements in nature. Well, they are so reactive, they're so desperate to lose that electron on the outside that they will react with anything. They will react with the humidity in the air just so they can be stable. And once they're stable, it's very hard to get them to react again, right? So that's why it's very hard to find them on their own, because they're highly reactive. We've got the alkaline earth metals, which is group 2 of the periodic table, and these ones are slightly harder and denser. Then we've got transition metals, which is this middle block over here. Okay. We've got the boron family, which is the group here that starts with boron. We've got the carbon family, which is this group here that starts with carbon. We've got the nitrogen family, which is this group here that starts with nitrogen. We've got the oxygen family, which is this group here. Over here we've got the halogens, and over here we've got the noble gases. Okay. Hydrogen is on its own. As I said, it's quite an exception. It's a very interesting element. The halogen group is over here, and these guys are also very reactive. And then finally we've got the noble gases, which are over here, and these guys are extremely stable. Why are they stable? Because their shells are complete on the outside. The electrons they have are very happy. They don't need to lose or gain any electrons. So that makes them extremely stable. Okay, so let's talk about some of what we've learned today. A column in the periodic table is called a group. A row in the periodic table is called a period. And remember, we've got 18 groups and we've got 7 periods. Elements in the periodic table are arranged in order of what? Increasing what number? Hopefully you know by now that it's an increasing atomic number or an increasing number of protons. Increasing number of protons. Nonmetals are found on the what side of the periodic table? Now remember what I said before. I said the elements in the periodic table are either metallic or non-metallic, and so everything on this side is what we call metals, while everything on this side here, the smaller side, is the non-metals. However, believe it or not, there's actually more. Just by pure numbers or amounts, the non-metals actually exist in greater numbers than the metals. So even though there's more metals, there's less metals in nature by amount than non-metals. So the non-metals, even though there's fewer non-metals, generally speaking, they are far more than the metals in terms of amount. Okay, so non-metals are found on the right side of the periodic table. Right side of the periodic table. Okay. Let's see if we can use the periodic table to answer the following questions. Identify the group and the period of the element K. Okay, so we should be able to do that. If we go back to our periodic table over here, so where is K? K is potassium. It's over here. What group is it in? It's in group 1. What period is it in? It's in period 4. Okay, so as far as you're concerned, that's all you need to know for now, is that you need to be able to identify the group and the name. So which group is it in? Group 1 and period 4. Compare the elements neon and sodium. Describe what you know about them from their location in the periodic table. Well, that's very interesting. Let's look over here. Where's neon? Neon is over here. It's in group 18. And sodium is over here. It's in group 1. And they are very different. Okay? So even though neon is got an atomic number of 10, and sodium has an atomic number of 11, don't be fooled. Okay, they are very different. In fact, even though sodium only has one proton extra compared to neon, however, when it comes to their properties, they're very different. Sodium is very unstable while neon is extremely stable. Why is that? Well, sodium is in group 1. This is group 1. And as you can see here, it is very reactive. Very reactive. How come? Remember, it wants to lose that electron so bad. It really wants to lose that electron. So it can form a complete outer shell. Okay, it doesn't like having that one extra electron. Well, what about neon? What's the deal with neon? Neon's in group 18. And what does it say about group 18? Group 18 are known as the noble gases. They do not ordinarily form compounds. Why don't they form compounds? Because they are extremely stable. Very, very stable. Very stable. They don't need any extra electrons. They don't need to lose electrons. They're very happy the way they are. Okay? So the difference is as such. Neon has an atomic number of 10, while sodium has an atomic number of 11. Sodium is in group 1, so sodium and A, group 1, while neon is in group 18. Neon is very stable, while sodium is very reactive. Okay? How are metals and nonmetals and metalloids different to each other? Well, metals are, as you probably know, metals are conductive, metals are sonorous, metals are malleable, metals can be magnetic, metals form colored compounds if they are transition metals. Nonmetals, on the other hand, are not conductive. Nonmetals can exist in gaseous forms at room temperature. Nonmetals are brittle. They're not malleable. They're not as shiny or sonorous or ductile, so they don't form wires like metals do. And metalloids, they're the kind of in-betweens. They can be semiconductors like silicon chips, but they're also they retain features of both metals and nonmetals. Okay, I'm going to give you some time to think about that one. I'll let you do that one on your own. Okay, let's do some of these revision questions. How does the type of element change as you go across the periodic table from left to right? Okay, it's going to change from metal to non-metal. Why is that? Because if we look over here at the periodic table, over here we've got the metals, and over here we've got the non-metals. So if we go from left to right, then we are going from metals to non-metals, aren't we? From left to right, so that means we're going this way. We're going from metals to non-metals. Okay. Which is highlighted in the periodic table here? Over here, what is that? That is what? A group or a period or none of them? Well, we should know by now that that is a group. Very good. What happens to the atomic number as you go from the bottom of the periodic table to the top of the periodic table? So this is very interesting. We're not going this way. We're going that way. What's going to happen to the atomic number as we go up? It's going to, let's have a look. This one here is 1. This one here is 87. So if we go up, it's going to decrease. How about this one here? It's 118 and that one is 2. This one here is 113 and that one's 5. So as we go up, it decreases, doesn't it? So what's going to happen is as we go up, it's going to decrease. Argon is shown in the periodic table. What can you predict about about argon looking at where it is placed? It's in group 18. It's in the noble gases, so that's going to be a non-metal and it's going to be very stable. The green elements are all what? Now remember, these ones are halfway between the metals and the non-metals. Over here we've got the non-metals. Over here we've got the metals, and these ones are in between. We call these metalloids. Argon is shown in the periodic table. What can you predict about argon looking at where it is? Oh, we've just answered that one. It's a metalloid. Oh, sorry, it's a non-metal. Argon is a non-metal because it's in group 18, as we said. So remember we said everything in yellow over here, it's going to be a non-metal, while the green is a metalloid. So argon is in this group here, so it's obviously going to be, oops, what did I do? So it's obviously going to be a non-metal. It's actually a gas at room temperature. Which is highlighted in the periodic table over here, that is another period. And what number period is that? That is 1, 2, 3, 4, 5. It's period and it's number 5. Okay, so hopefully you should be able to do this by now. But generally speaking, over here are the non-metals. Over here are the metalloids, and everything over here is the metals. Very good. Okay. Now you might see different periodic tables. You'll see them slightly different, but more or less that's what we have. Okay. Let's do some of these quiz. Rows in the periodic table are called what? Rows, not columns. Rows are known as periods. True or false? Mendeleev's periodic table had 118 elements. That's of course a false. Mendeleev did not know the 118 elements. He predicted that there will be more, but he didn't have 118. True or false? The chemical symbol of each element is found in the periodic table. Yes, it's true. True or false? Most of the elements in the periodic table are non-metals. So what I want you to do is I want you to pause the video and answer it yourself before I reveal the answer. Most of the elements in the periodic table are non-metals. That is false. Most of the elements in the periodic table are metals. That is the big portion on the left. True or false? Elements in the same group are similar to each other. Yes, it's true. True or false? Isotopes are found in the periodic table. No, they're not found in the periodic table. True or false? The state of matter for each element is found in the periodic table. No, it doesn't say the state of matter. It doesn't say whether it's solid, liquid, or gas. And isotopes have the same mass number. No, they don't, because they have different number of neutrons. What is an isotope? It's an element that has the same number of protons and different number of neutrons. Okay. Where in the atom are protons located? In the nucleus. What is found in the center of all atoms? The nucleus. Which part of an atom is negatively charged? Hopefully you know by now that it's the electrons. The right side of the periodic table has non-metals or metals? It has non-metals. Metals and non-metals are separated by metalloids. What information does the mass number give you? It gives you the mass number is comprised of neutrons and protons. Where in the atom are the neutrons located? It's inside the nucleus itself. Which part of an atom is positively charged? The protons. Hopefully you know that. All elements are organized in the periodic table by their number. By their what number? Atomic number or number of protons. The left side of the periodic table has metals. Columns in the periodic table are called, the columns are called groups, while the periods are called, well, the rows are called periods. Okay, that's it. Thank you so much for listening. I will see you on the next one, inshallah.